Hello, lab rats. So this should be a quick one for you, and feel sorry for your junior counterparts. They had a really long chapter here, and that's because our lessons sort of separate a little bit and then come back together pretty quickly. But we are going to do our part two of soil weathering, erosion, and mass movements. And this will be the last virtual lesson and the second part of the virtual lesson you guys had last week. So mass movements. We're going to talk about several different types of mass movements today. So what causes these mass movements? Some influential factors include the weight of the material's resistance to sliding, and seismic activity. All in all, these are all caused by gravity. And gravity's effect on these factors here can give you an idea of what type of movement will occur, whether or not it will be something with a small impact or something of great impact. And so keep that in mind as we move through all of these different types of mass movements. So creep, here's your slow, steady downslope flow of loose material. And this can happen on steep hillsides, but you see good evidence of this on more sort of less steep hillsides. So right here, you can see this tree, for example, let's use him, he's in the foreground, has taken root here, and as it continued to kind of grow, the area it was growing in slid down and eventually got to the point where it could stand up on its own, and it just went up to the sun. And as you can tell, these larger trees are less affected than these the skinnier, more narrow trunks, the newer trees. So that can tell you that both the large ones are less susceptible because their roots are spread out further in this area, and also they may have lived through this type of thing in their earlier life. Then we have flows. We have a couple different types of flows. First type we're talking about here is a mud flow, which is defined as a swiftly moving mixture of mud and water, which I find funny because mud is just dirt and water. So it's really a swiftly moving mixture of watery mud or muddy water. Do it either way. But I feel bad for whoever owns those houses. That's terrible. Another type of flow is a lahar. So this is a mud flow that follows a volcanic eruption and also contains ash. So these are particularly messy and particularly devastating. Slides. Okay, so no more flows. Now we're into slides. So slides, we have a landslide, and this is when material separates from the bedrock. And it's more common on a steeper slope, unlike the creep, which we talked about before. And everything comes down in like a sheet. You can see here where these trees have been knocked loose and everything came down the hill at one time. And these poor guys at the bottom got pelted. This group of people here, if they didn't think they had enough trees in their backyard before, they have them now. They have everyone's trees in their yard. Here we go. Slides that involve rocks are rock slides, and this is a sheet of rock that slides down slope. Now, this is different from a rock fall. So a rock slide is a sheet, and this is a road. I'm pretty sure this was actually part of the Pacific Coast Highway. So whoever lives here, I hope they don't need to go this way because they're not going to get there for a while. That would have been devastating cleanup. I can't imagine. Another kind of slide is a slump. So this is when you have a landslide over a curved surface. So it tends not to go as far as when you're considering the distance covered. But you see these on, like, this is a mountain slide, right? It's going up this whole area. So this is it's like a landslide within a slope, but it doesn't necessarily come all the way down. And then another kind of slide would be an avalanche. And you might not think of these when you're thinking about types of slides because you are probably thinking more along the lines of soil or rock. But in this case, the ground covering is thick snow, and it will slide right down the surface of a mountain, and it will tumble and stuff. But all of that stuff under the bottom is doing its best job of sliding. And the reason I mentioned that it does tumble is rock falls. So rock falls are different than rock slides because you're talking about a rock or a group of rocks that come loose and tumble down slope. So these are like the kind of things you can expect along mountain roads. And you'll see a lot of, there can be like little cages and fences and things along the sides of those mountains to try and keep this from happening. So rock slides and mud slides and all these different kinds of natural disasters can affect everybody all over the world, even Oprah. So this is Oprah's posting picked up by some news stations several years ago when there was wildfires not too far from her home, and that caused a really bad mudslide.
Less than 48 hours after Oprah Winfrey's inspiring speech about equality at the Golden Globes, Oprah woke up to a scene of devastation unfolding at her Montecito back door. Mark Brown has the story.
That's a huge flame shooting into the sky just beyond Oprah Winfrey's backyard. She took this video of the unfolding Montecito mudslide disaster this morning and posted it to her Instagram page. You can see the rain still falling. In her post, she says, "What a day, praying for our community again in Santa Barbara." Oprah then posted a second video of all the mud in her backyard.
This is how deep the mud is. And the house in the back is gone.
Oprah also posted this video of a helicopter she says is rescuing some of her neighbors and looking for missing people.
Well, Oprah has some famous neighbors, and today actor Rob Lowe tweeted this: media talking about Oprah may be running for president in 3 years. Meanwhile, as we speak, her Montecito home's a staging ground for helicopter rescues. Priorities, anyone?
Rob Lowe, talking about priorities. Yeah, and I do think also that Ellen DeGeneres' house was right in that same area. So it's quite a lot of mud. You get some mud and you get some mud. So reducing risks. So here are some ways we can divert water. We can net hillsides, which is what I was talking about before. Here's an example right here. We can stabilize at-risk areas. That's right here. And we can decide not to build in ridiculous, unstable areas. Whoever built here probably had a beautiful view and a lovely life until this happened. And then they started regretting their choices. This right here, we see these pegs. You may see these or similar ones if you take some drives up in the mountains. These are actually big, long metal pegs that they drive down into the rock. And it helps, sort of like rebar, but it helps stabilize the hillside. I'm going to leave this here for a minute. You can see why. It's obvious why. Everybody should watch this for a minute and contemplate life. Yeah, that's amazing. So wind erosion. Here are some forms of wind erosion. We've talked about this before: surface creep, saltation, and suspension. That's a lot of suspension going on right there. A lot. So deflation is what happens when wind erosion lowers the land surface, and that's because the wind removes particles. Now remember, if they're going to get eroded and removed, then they're going to have to be deposited somewhere. And that's how you get a lot of dune shifting. But deflation doesn't have to form a big pit like it did in this case. It can happen. You can see it in other places as well. But right here, this is a really obvious one. So another way is by abrasion. So when we talk about both wind and water erosion, we have to remember that they're both fluids and they're both going to follow the same basic laws of fluid mechanics and physics. So when we think about, you think about river rocks and how they are eroded by the suspended particles of sediment and sand within the water as it moves over, and it erodes the surface of those rocks and smooths them. Wind abrasion is kind of similar. It's like natural sandblasting. And this because you've got particles of sediment, which in dry areas tend to be sand, traveling through the wind by means of suspension. And they don't tend to smooth as much as the ones within water, but that's also because you have the water doing some dissolving as it goes by. But ventifacts are what is left behind. And these are stones that have been worn, polished, or faceted by windblown sand. So this tends to be the hardest of the rock in an area. So if you look, you can see future ventifacts here, 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 and here, and even here. So as the wind continues to deflate the surface and simultaneously abrade the structures that are left behind, you'll get really interesting shapes like this one here. And this is where you find things like Monument Valley. This is what you'll find in Monument Valley and similar places. And yes, this does tend to occur in drier areas more often. And that is because when you have less vegetation to hold down the sand, soil, sediment, less of it will erode. It's also drier and therefore looser, as long as it's not heavily compacted, but it's easier to move dry sediment than it is wet sediment. And then lastly, these are the places where you tend to find sand. And part of that is because as it blows, it's doing what? It's abrading a rock, which is making more sand. Yep. So you will get, this is why you get structures like this in the desert, and also why you end up getting things like sand dunes that shift around. And there are dunes. So dunes are piles of windblown sand, and dunes don't tend to stay in one place. They shift, they move, they constantly change shape, and that's because the wind's constantly moving. These are desert dunes, but you can also find dunes along a beach, and they tend to be the sort of structure that separates the beach from the land. And they're very important, and there are usually signs around them that say to stay off the dunes or leave the dunes alone. And that's because they form a natural barrier between the water of the ocean and the inland area. And they also form an important habitat for certain critters and also some types of plants that live in that area. You'll often see a lot of reeds growing within sand dunes at the beach, and that does kind of help hold the dunes in place too. They sort of symbiotically work together there, the dunes and the seagrass or sea reeds. So then we have less, and this is thick windblown silt deposits. And this is a great example because you can see the layers here. And these are layers of sediment that have been, or silt that have been blown over time. And over time, it made these clear deposits where you can see the lines. And then as the wind has blown later in time, it has shaped this land by cutting through here and blowing around. And eventually, if there's any rocks within here, you'll see some ventifacts. You can see along here where this has been deflating and the rock is more obvious because it's kind of poking out on top. Now, glaciers. When glaciers have chunks that fall off like this, it's called glacier calving. And if you want to watch some cool videos, there's lots of glacier calving videos on YouTube. And they can be a little nerve-wracking because usually they watch them from a little boat, and they can cause some pretty big waves. You can see this little wave starting, and it's going to be much bigger when that whole thing gets in the water. So you tend to be on these little boats that are rocking around like crazy. That's not for me, but if that's for you, make yourself a trip one day. Go to Alaska. So here is a glacier. Once again, we know it is a large moving mass of ice. And you can see this glacier goes all the way back. This is all one glacier, and it goes this way too. So we have two main types of glaciers. We have our valley glaciers, and they form in, guess what, a valley. Look at that. And they also shape the valley. They form in the valley, and they shape the valley as they move. And you can tell here that the leading edge of this glacier is melting, or maybe some of this area around it is melting. And it's formed a little waterfall that comes down into this big lake. And then you have your continental glaciers, and these cover broad continent-sized areas. So you're thinking Antarctica and actually most of the land in the ice ages. So they leave behind certain structures, and these are evidence of glacial erosion activity. So you have a cirque, that's this little round thing right here, little circle. And a lot of the times there are little lakes in the bottom of them. You have a hanging valley. So that's this thing right here. So just to note, rivers, when they form valleys, they tend to be V-shaped, very angular and steep. When glaciers form valleys, they tend to be more shallow and U-shaped. And this is a perfect example of a U shape. So hanging valleys, these are created when two glaciers meet and then retreat. So you probably had a glacier coming this way, and then you had another glacier coming this way, and they met, and then they just kept moving on. And this one was a little deeper than this one, and you've got this big, huge waterfall that comes off of this. Is really high. And you can tend to get these nice high waterfalls when you find hanging valleys. They're really pretty. So moraines, these are unsorted ridges of till. So till is what a glacier leaves behind. It's the sediment, rocks, whatever that a glacier picks up as it dumps it, it's called till. And if you think about those old school plows, the kind that like oxen pull or even a person pushes, and they dig through the farmland and they kind of push the dirt out to the sides, that's exactly what you're thinking about when you're thinking of glacial till. It rips along and it's like a giant plow tilling the land. So till is the stuff left behind, and moraines are the unsorted ridges. And you can tell this is unsorted. Like the big rocks are both in the top and the bottom. The little stones and little particles are in the top and the bottom. And in a minute, as we look at some more structures, you'll see how the unsorted till is a hallmark of glacial activity. So here you got an outwash plain. This is when the leading edge of a glacier starts to melt. You have meltwater flowing out of it, and the deposits come with it. So all this mess in here, where you see all these unsorted sediments, this is an outwash plain. So the leading edge of a glacier is, when, if you want to think about it as the front, and as it melts, it moves that leading edge back, but the glacier tends to still kind of be moving in a forward direction. So there's a lot of stuff going on, movement of the front edge back, but movement of the entire body forward. So you get these big areas that are covered with unsorted till, but it's more spread out, and that's an outwash plain. And you can see some of this like in the more central US area. Drumlins. These are drumlins, and these are these landforms that are made when a glacier moves over older moraines. So these moraines may have been from that glacier itself, and it's changed shape or course, or they could be from another glacier. But you have these unsorted ridges of till, and then you have a glacier that moves over them. So you can see the ridges probably went kind of this way, and then I'm thinking the glacier went that way. And that's how you get these, or maybe it was more at an angle really, but that's how you get drumlins. And they're really interesting landforms like that. You tend to see them in big, wide, flatter areas like where you find farmland. And these are my favorite. This is an esker. Eskers are just cool. I don't think I've ever seen one in person, but I love pictures of them. So this is when you have a stream flowing beneath the glacier. So you've got a big, huge block of ice, right? And then underneath of it, you have water flowing. And as it flows, part of that water is going to cut into the ground and pick up sediment. Part of that water is going to be cutting into the ice above it. And it's also going to pick up sediment there. And it's also going to deposit sediment there. It's going to stick to that ice as some of it goes by. But over time, it creates this big ridge of till. So you can almost see this like an upside down stream. As you can imagine, it's easier for water to sort of deflate the surface of ice or melt the surface of ice than it would be for it to cut into the ground. It's going to take less energy to just melt a little as it goes. So this is almost exactly like an upside down stream, like it's been flipped over. And you can see this big, long, winding esker. And they do tend to be in larger flat areas like that. You have a kame, and a kame is a conical mound of layered sediment deposited at the retreating edge of a glacier. So that would be the back end of the glacier, if you want to think about it based on the direction it moves. Glacial lakes. Who doesn't love a glacial lake? So this is what happens when your glacier erodes an area of land and then it melts and it fills it in. And this does tend to happen in mountainous areas. And I want you to look right here. There's a nice U-shaped valley. See this? Clear evidence of glacial erosion. If you look right here, there's another U-shaped valley. And what do we have where the two come together? Right there. You've got a little waterfall and a hanging valley. It's right there. You can really see that one. And so a lot of these tend to be up really high. Oh, also notice right here, alluvial fans. See, from where the water comes down as it melts off this mountain, probably in the spring, or just flows down with rainfall. So a lot of these tend to be up in the mountains. They can be like almost in the middle of a bigger mountain or a range, and they can be really blue and quite gorgeous. And then you have kettles, and these tend to be in flatter areas, and they're formed by a depression that's made from a block of ice that broke off a glacier, and then it melts there and fills it in. Or sometimes it just makes a good depression that stays wet enough that when it rains, it continues to fill it. So that it's not like the whole thing was overflowing necessarily with glacier water to begin with, but makes a nice little pond in the middle of nowhere. So here you go. Here are your answers to your binder material. I'll leave this one up for a second. And then this one. So I hope you guys continue to have a wonderful rest of our virtual period here. We're almost done. I'll be back soon. And have a good one. Miss your faces.